So I hope you've had a chance to try this one on your own. We're going to go through the same process here, and we're going to take a look at the cosine function and try to sketch the derivative of the cosine. So the first thing I'm probably going to do is look at what's happening with the slope of the function. And so you can see that in this portion of the cosine function, between negative pi over 2 and negative pi, it looks like it's decreasing, right? The function is decreasing, which means the slope is negative, which means the derivative is negative. And if the derivative is negative, it's going to be below the x-axis, okay? And then you can see it looks like it turns around here. So the derivative of the cosine function at this point, at pi, is 0. Okay, so I'm going to cross the x-axis at negative pi. So let me just sketch that in. All right, now it also looks like maybe, it's kind of harder to tell here, that the slope may be 0 here as well. And in fact it is. So we can also show ourselves crossing the x-axis there. All right, so it's negative, right? Between negative pi over 2 and negative pi, the slope of the function is negative, which means the derivative is below the x-axis, okay, because it's negative. Okay, and then halfway in the between, we're just going to sketch that in. So all the way from negative pi over 2 to negative pi, it's below the x-axis. All right, and we turn around at negative pi. Right now, the slope looks like it's positive, right? The slope is positive, which means the derivative is positive, which means derivative is above the x-axis. All the way from negative pi to 0. Okay, so from negative pi to 0, we're above the x-axis, and here it's looking like the derivative is turning around again, right? So the derivative is 0, and then the slope of the function is going from positive to negative. The function itself is going from increasing to decreasing. All right, so it's going to cross the x-axis again at 0. So let's sketch that in. All right, it's above the x-axis all the way from negative pi to 0. All right, and then the function is decreasing again until you get to pi, where the derivative is 0 because the slope is 0. Okay, so it's going to cross the x-axis again at pi, and between 0 and pi, it's going to be below. The function is going to be below the x-axis because the slope is negative. All right, so that kind of sketch that in, and then finally here the slope is positive again. Oops, should be positive, and then it looks like here it's also this. Oops, dy dx. Dy dx. The slope is 0, right? So dy dx is equal to 0. All right, so at 2 pi. And then because the function is increasing, the slope is positive, and the derivative is above the x-axis. All right, there's a sketchy sketch for you. Now, take a look at that. What does it look like? What does that look like? Well, so sine of x, you know what sine of x looks like? It kind of looks like sine of x because I'm starting at the midline and returning to the midline over one period of 2 pi. But I'm going down first, right? It's negative first, and then at pi it's positive. So you know that sine looks more like this. It goes positive first. That's a little bit. But it's actually the negative sign. So the derivative, d dx, of the cosine of x is equal to the negative sine of x. You'll have to take my word from that, but based on the sketch, it looks like that's probably a good bet. All right. So, and I would tell you that it is true that the derivative of cosine is negative sine. All right, I will meet you in the next video to do some practice with using the derivatives of sine and cosine.